Okay, ladies and gentlemen, you can just label, if you want to put a name to your Google Doc, you can put that name as stoichiometry. It should be coming up on the smart board here. How to spell it. Stoichiometry. It is actually a word. I can remember one time Mr. Metz walking by and saying, I've never heard of that. That isn't even really a word, right? And I go, no, it is. It is a word. Stoichiometry. Now, what you're going to see about stoichiometry is it will include almost everything that we have done thus far. So, let's stop and talk about, we needed bonding to understanding how to name. So understanding naming dealt with bonding. Well, if you couldn't write the formula for a name, could you balance an equation? Could you get the molar mass? Could you do all the flux capacitor stuff? No. Then also we can take it even further that we could have a reaction that you would have to predict. Just like we did with the 5 different ways. The composition, the decomposition, single replacement, double replacement, combustion. So you could have to do that all put together into this big pot called stoichiometry. Now let's review a little bit of what a balanced chemical equation will tell us. First of all, it lets us know all of the elements that are involved in the reaction. It tells us the number of atoms of each individual element. A balanced chemical reaction tells us the moles involved in that reaction. It can tell us the mass. If we use our periodic table to look up the molar masses of the elements. A balanced chemical equation will also tell us the number of particles. Remember, Avogadro's number, 6.022 times 10 to the 23rd, gives us the number of particles, whether it's an atom, whether it's a molecule, whether it's a formula unit. It also gives us the volume if. If what? STP and what else do we need? STP, and it has to be gases. Good. STP, and it has to be gases. It tells us the volume. Also can tell us the density. If we have a molar mass and we have a molar volume, we can get the density. So if we're dealing with that density, obviously, the 22.4, the volume has to be at STP and the gas also. Now, stoichiometry problems are classified according to dun, dun, dun. The information that is given in the problem and the information you're expected to find. Your unknown. So basically, how we classify these? What you know and what you're trying to find. What you know and what you're trying to find. So, in the next couple of weeks, we'll be dealing with all of these types of chemical stoichiometric problems. For instance, we can convert from moles to moles. That is what we'll focus on today, and probably a good portion of this week and next. I don't think we're going to get to mass until maybe Monday, Tuesday of next week. So we'll be going from moles to moles, focusing on that this week. We can go from a mass to moles. We can go from moles to mass. So kind of the flip side of mass to moles, moles to mass. We can go from a mass to a mass. We can go from a mass to a volume if we're dealing with gases at STP. Well, if we can go from a mass to a volume, we can then go from a volume to a mass. And, bless you, and then finally, we can go from a volume to a volume. Now, you're looking at these, and you're probably trying to relate those to the flux capacitor. And let's look at this very top one here that we're going to be working on today right here. Moles to moles. Well, on the flux capacitor, that's in the center, right? So you're probably asking yourself, how do I go from a mole to a mole? It's in the same square. Well, this combines the flux capacitor with balanced chemical equations, which we haven't done yet. Okay, when we were converting using the flux capacitor, we would be going from a mass of one substance to moles of that very same substance. Well, we're going to expand on that today. So in order to go from moles to moles, we are going from moles of one substance to moles of another substance. In order to do that, we need a balanced chemical equation. Why? Because it gives us this guy right here, the mole ratio. mole ratio? The mole ratio is a conversion factor that relates the amount in moles of any two substances involved in a chemical reaction. Now we could even go further to say it has to be a balanced chemical reaction. Because if it's not balanced correctly, you're going to see that the mole ratio is not going to be correct. So the mole ratio is a conversion factor, and we're just going to use that in a conversion box, just like we have been doing. Just like we have been doing, or just like how I have asked you to do these problems. Now, like I said before, some people are still plugging and chugging them into the calculators and not showing their work. Here's where it's going to catch you. Now, the mole ratio is obtained directly from a balanced chemical equation. So the mole ratio comes from the balanced equation. Go back, I'll give you a little extra time here. Thought I had something else there. Here is a balanced chemical equation. So go ahead and write this down. Okay, I'll give you a second to write it down. Now, when I try to determine the molar ratio, I'm looking at the balanced chemical equation. Now, first thing we need to check, is my equation up here balanced? It is balanced, okay? It is balanced. So what are some of the things that I know from this? Well, let's go back. We know all of the elements involved, right? We know we have aluminum oxygen involved in this reaction. What type of a reaction is that? A decomposition reaction. We could get the masses of all the different ones by the periodic table. Could we get the volumes on this one? We're not dealing with gases, so we don't want to do that. Okay, we don't have a molar volume of a solid. So we can't use the volumes here. But we can use masses. We can use moles also, folks. You just don't know how to do it yet. Or you probably do, because we talked about this. All right? If we have 2 moles of aluminum oxide, it decomposes to 4 moles of aluminum and 3 moles of oxygen. So where did I look? What number is telling me the amount of moles? The coefficient in front of the particular compounds or elements. So as I'm looking at this, and I'm asking the question, what is the molar ratio of aluminum oxide to aluminum? How many moles of aluminum oxide do we have? 2. Okay. We have 2 moles. All right, clicker. 2 moles of aluminum oxide. To how much aluminum? To 4 moles of aluminum. So, my molar ratio of aluminum oxide to aluminum is 2 moles of aluminum oxide over 4 moles of aluminum. I don't reduce them, no. Okay? I don't think it's going to matter. Okay? If you would reduce it, it's not going to affect your numbers, but all you're doing is typing the number in the calculator. Okay? It shouldn't change your values, because whether you're doing 2/4 or 1/2, it should come out to the same. Okay? I wouldn't bother reducing it. I never reduce it. Okay? I just go with the molar ratio that is given. All right? So I'm saying don't reduce it, but it shouldn't affect your final outcome. Do we all understand where we got the numbers? The coefficient by whatever the subscript is. We're not multiplying anything here, Remington. We're just looking at coefficients. So, if I'm looking right here at my aluminum oxide, okay, I come back to my balanced equation, and it says a 2. So that's where I get my 2 moles. So for aluminum then, I say, okay, here's my aluminum. What is my coefficient for aluminum? 4. 4 moles. Okay? So we're not multiplying anything together here yet. We're just looking at coefficients. So let's take a gander at another one. What is the mole ratio of oxygen to aluminum oxide? Okay, we're still dealing with the same equation, so you shouldn't have to copy that again. Type that out. Just type out the question. What is the mole ratio of aluminum oxide to aluminum? As I come up here, I look at oxygen. O2. What's my coefficient for oxygen? 3, right? So, that's telling me that 3 moles of oxygen over Al2O3, we already knew what that was. It is what? 2. So my molar ratio of oxygen to aluminum oxide is 3 moles of oxygen over 2 moles of aluminum oxide. So once again, just to reiterate it again, okay, where are we getting these numbers for the molar ratio? The what? The coefficients in the balanced chemical equation. Let's try one more. Let's try one more. Now the question is posed here, what is the molar ratio of aluminum to oxygen? Once again, looking at our balanced chemical equation, we have 4 moles of aluminum to every 3 moles of oxygen. Not necessarily, because aren't aluminum and oxygen both in the reactants? Or excuse me, check, in the products? So it doesn't matter, okay? What this is telling us is that if we have so much of this, we should produce so much of this and so much of this. So if I would have 4 moles of aluminum oxide, okay, if I would have 4 moles of this, how much aluminum should it produce? 8 moles of aluminum, and how much oxygen should it produce? 6 moles of oxygen, okay? Because we're just looking at the balanced equation, okay? If I would have 10 times the amount of aluminum, okay? If I would have 10 times the amount of aluminum, here, how much would this perform, or how much would this produce? 10 times the amount, okay? So if I had 20 moles of aluminum oxide, it would produce 40 moles of aluminum and 30 moles of oxygen. So we're just relating the balanced equation. Could we then, we're not going to, but could we then put those into masses? Because we know what 1 mole of O2 is, right? We know what 1 mole of aluminum is. We know what 1 mole of aluminum oxide is, correct? So could we put those into masses? Absolutely. That'll be next week. Okay, we're going to baby step this, and this is our first baby step, getting the hang of this molar ratio guy. Okay? Now, I'm going to give you a second. We're still dealing with that same equation. I'm going to give you a second to write down this question. Now, here's the entire deal with the molar ratio. We are going to use it to convert something of a known quantity into an unknown quantity of a different substance. So in this particular equation, we're going to say, to start with, okay, what do we know? What do we know? What have I been given? Well, I've been given that I have 13 moles of aluminum oxide. That is my given. So, I have 13 moles of aluminum oxide. The question asked me to calculate what? Moles of aluminum. So, I need to go from moles to moles. Moles of aluminum oxide to moles of aluminum. So we're going to do it the same way we have been doing things. We're going to write down what is given to us. 13 moles of aluminum oxide. In order to calculate my moles of aluminum, I'm going to use the conversion factor of a molar ratio. All right? So I'm going to use the molar ratio The only thing you have to figure out is, what do I put on top? What do I put on bottom? I've got my conversion bracket. What goes on top? What goes on bottom? And the question you ask yourself, first of all, is, what do I want to cancel? What do I want to cancel? Moles of aluminum oxide. So where am I going to put that to get it to cancel? On the bottom. So, how many moles of aluminum oxide? Right? As I look at my balanced equation up here, isn't that 2 moles of aluminum oxide? Absolutely. What am I going to put on top now? What am I going to put on top of my conversion bracket? What am I trying to go to? Moles of aluminum. Well, how many moles of aluminum are in my balanced equation? How many? 4. Now, if I look at that, I go back and double check. Am I getting a cancellation that I want? Moles of aluminum oxide, moles of aluminum oxide. So what's my final answer right now going to be labeled? Moles of aluminum now, when I do my math, we have been multiplying by the top, right? We've been multiplying by the top. So what I'm going to do is I'm going to take 13.0 and multiply it by 4. Once I do that, I get 52. I'm going to do what? Divide by 2, because that's on the bottom. And when I do so, it gives me 26.0 moles of aluminum. Yeah, Sean? No, because you have to use the ratio to get the answer. Right. We can't guess on what the comparison is. We need that balanced equation to compare how many of one break down into how many of the other. Okay? Yeah. Ethan? I would do it like this, okay? Because if I replace this 2 right here with a 13, okay, you're going to get all confused because my molar ratio has nothing to do with that 13 there, okay? It has nothing to do. It has everything to do with the balanced equation. The molar ratio is totally independent of that 13 right there. Okay? So, I'm kind of thinking here that Ethan, you wanted to take and put a 13 right here. Okay? Now, is that going to balance out your equation? What are you going to do? Okay? I wouldn't do that. That's going to be tougher than what we're doing right here. Okay? He's saying put a 13 right here and rebalance the equation. I'm not going to say that that wouldn't work. I'm going to say it's going to be easier to just use this ratio right here. Okay? Now, can you give me a thumbs up right now? Okay, the people right now, you people that aren't giving me a thumbs up should be asking questions. Okay? Why am I not getting a thumbs up? Okay, who wants to speak up that doesn't have a thumb up? Garrett? Why do I put the 4 here on the top? Okay, the question asked by Garrett before we left is, why is 4 mole of aluminum on the top and 2 mole of aluminum oxide on the bottom? Isn't that the question? Okay. We have to go back and look. What do we want to cancel? If I have mole of aluminum oxide here, and I would change this, okay, let me just flop this here to show you. I'll get this off of here. Let me flop it and do it the other way. And say, okay, I'm going to get that canceled out of there. So I got 13 mole Al2O3, and I'm going to convert this into as I look at that, do I get a cancellation here and here? Do I get a cancellation there? No. So if I would look at this, my actual label would be mole of Al2O3 squared over mole of Al. Is that anything near what I want to have? No. Okay? I have to get a cancellation to convert from one thing to the other. Remember when we were converting from dozen to donuts? Dozen to donuts, this is the same thing. It's just something we're not nearly as familiar with. So, I have to get that cancellation to occur. So in order for that cancellation to occur, I look and see what value I was given. So I'm going to put 2 mole aluminum oxide and what value I want to find. And that way I can get this right here to give me that final mole of aluminum. Okay? So that cancellation is the big thing. This is why, people, this is why I've been telling you to make sure you have labels. Make sure you have labels, because here's how I see people doing this. Here's how I see people doing this. They say, okay, I've got 13 of that. Then I do my conversion box, and I go 4 over 2. Now, does that tell me right there that I got to cancel? No. If I plug it in my calculator wrong and put 2 over 4, do I see anything about that cancellation without that label there? No. Okay, that's why I've been telling you to make sure You use conversion box, you use labels. Don't just plug this junk into your calculator. Okay? All right. Now let me see. Go ahead and copy down this example. Once you get it copied down, we'll go through it.